Hello class, today we're going to be moving on to the long division polynomials, and we're going to be tackling on some questions that deals with higher degree polynomials such as cubic, quartic, and things of that nature. Your quadratic test as of yesterday has been completed. For those of you who still need to turn it in, make sure you submit it by the end of today. Um, uh, Besides that, I don't believe that we are going to go back to anything that has to deal with, uh, you know, um, axis of symmetry, quadratic formula, and things like that. We spent a long month over it, and to be honest with you, that was one of the biggest topics of Algebra 2. Any Algebra 2 teacher will tell you that. So give yourself a pat on the back for accomplishing something. Finishing up a very big portion of an Algebra 2. And the rest of the topics that we're going to be talking over after this, which is now polynomials, radical functions, rational functions, they're going to be relatively much quicker to go over than quadratics would ever be. Unfortunately, because it's online, I'm not sure how slow the pace is going to be because there's limitations to that. But I believe that we can get through these things pretty quick, given the fact that this is advanced class and you guys are very quick with picking up things. But first of all, we'll talk about the long division of polynomials for today, and you have 4 questions to do for homework, and that's it. Your homework will now be relatively very simple, where you just have to do a couple of questions a day, just kind of like check in with me that you did do work assignment on time. So if we decide to go all virtual for the remainder of the year, until maybe January or February, please expect that your work uploaded on Schoology will be very much less in terms of the quantity wise. Okay, so first let's go to the example question. So now we want to find out the factors of cubic polynomials. Now, when you're doing questions like these, for example, like it's really not simple because you can't do this, like open up 3 parentheses because now you have x cubed. Oh, so let me try 2x and x and all these numbers that multiply to give you 2. But, it's not as feasible as doing the AC method that I taught you before, or doing the 2 numbers that multiplies to give you this number and adds to give you these. It's not going to work like that because obviously it's not quadratic. So how do we factor cubic functions? Well, there are 2 ways. One of the ways is obviously the thing that I'm telling you about, which is called long division, and then later on I'm going to tell you something about synthetic division. Now you will tell me that, oh wow, synthetic division is much easier to do. Why do we have to learn the long division way? Well, because I want you to also learn how to do both of the ways when you're solving for polynomials, and sometimes the synthetic division will not work, where you only have to do long division in certain cases. So I need you to be fluent in how to utilize both of them. Okay, so let's go over the basics of long division. Now let's go back to maybe kind of 3rd or 4th grade where we're doing long divisions with this type of question. So if I give you 370 divided by 5, instead of typing in the calculator, if you were to ask to do long division, what would you do? Well, you would ask yourself, okay, how many times can 5 fit in a 3? Well, there are none of them, so you bring down the 3 as well as the 7. Now you can say, okay, 5 fits in 37 7 times. So you write that up here. So you write 35 and you always subtract. I hope everyone remembers that. 37 minus 35 is 2. Bring down the 0, and 5 goes into 24 times. So we get minus 20, which gives our remainder to be 0. So our answer here is just simply going to be 75. This is called a quotient as a result of dividing by the divisor. And we call this the divisor. And the remainder is simply just going to be whatever you get at the very, very end. So you're going to apply this to this, where I say, okay, x cubed minus 4x squared plus 2x minus 3. And you're going to divide that by x plus 2 like this. Okay, so now how do we go on about doing the long division part? Well, you ask yourself, once again, how many times can x fit in x cubed? Okay, that's it. The very first terms of each of these guys. Okay, because you can't really think about the rest of it. Just focus on the first term of the divisor and the dividend. So x into x cubed. Okay, so how many times can x fit in x cubed? The easy way to think of it is just always take the dividend by the divisor, just divide them, and so you get x cubed, I mean x squared, right? So you write x squared up here. So x times x squared gives you x cubed, and then you also need to distribute the 2 with the x squared, so you write that down here, plus 2x squared. And then what was the next step that we did after we multiplied? We always subtracted them, right? So we are going to subtract from top and bottom. So x cubed minus x cubed here will just simply cancel each other out. Minus 4x squared. Now here's where you need to be careful. The minus sign distributes to here as well. So this actually turns out to be minus 2x squared. So minus 4x squared minus 2x squared becomes minus 6x squared. Bring down the plus 2x. And then now you are going back to square one. You want to highlight, I'm going to use a different color, highlight the x, highlight the negative 6x squared, and ask yourself, how many times can x fit in negative 6x squared? Well, that's exactly minus 6x times, because by multiplying x with negative 6x, I get minus 6x squared. Plus 2 with minus 6x, I get minus 12x like this. And then I want to distribute the signs one more time. Well, I'm going to leave it like this actually. And you want to distribute the signs one more time because you're subtracting them. These two will cancel out. This is plus 2x plus 12x. That's 14x. Bring down the minus 3. And so my final portion will be, to complete this, I'm going to just move this up just a little bit more. So how many times can x, again, fit in the 14x? That's simple, that's plus 14. So you distribute that one more time, so you get 14x plus 28, and you will subtract these two together, cancel these out, and this becomes a minus 28 because you need to distribute the negative sign to both of these guys. So you get minus 31. So this becomes what we call our remainder of the function. So how do we write our answer as a whole? Well, we always want to write our answer in terms of quotient plus the remainder over our divisor. Because technically speaking, you still have to do the same process where you have to do negative 31 divided by x plus 2. In other words, how many times can x fit in 31? Negative 31. Well, you can't, so you have to stop there. This is how much you get, right? So the final answer that you're going to write it down, it looks like this. The quotient, which is x squared minus 6x plus 14, that's the part that you have up here. And the remainder, which is minus 31, but you're going to have to put that over our divisor, which is x plus 2. And this is how I would write our final answer. Now, if there is no remainder, obviously then your answer would just simply look like a quadratic function. But because we do, we have to leave our remainder in a format of remainder over our divisor. Okay, now take some moment of your time to try doing this question. Oh, actually, I'm sorry. I'm going to actually have to teach you this part where sometimes they're going to give you questions that's missing some portions. So again, 3x cubed minus 2x squared plus 5. Now notice how there is no x in here. Now that's a really important key feature that I need you to understand, which is that when you do not have a variable like that, you have to fill it up with plus 0x plus 5. So in other words, if I have a cubic function, I need to have 4 numbers. The cubic, the quadratic, the linear, and the constant. And you're going to put that divisor over x squared minus 1. Now you can practice doing it on your own. You can pause the video and then check to see if your answer is correct. Okay, so again, here what we do is we want to just highlight the very first term of each time and then ask yourself how many times can x squared fit in 3x cubed. So that's 3x times, so it's 3x cubed here. Then minus 3x because I need to multiply those two together. Now the problem is I cannot combine the negative 2x squared with minus 3x. But first, let's write down the minus sign. So this becomes minus 3x cubed, so these two would cancel out. The minus sign distributes to here, so it becomes a plus. These two can't be combined, so what do? We write it as it is, minus 2x squared plus 3x. You bring down the plus 0x, but that really serves no purpose, right? So then you now have the x squared and the minus 2x squared. I'm going to highlight the first term of each thing that we're looking at. So here we can say minus 2 because minus 2 times x squared becomes minus 2x squared. And then minus 2 times negative 1 is plus 2. So now I want to subtract these two and these will cancel out. So now that becomes 3x minus 2. Now you bring down the plus 5. This becomes 3x plus 3. Now here, notice how I have an x and I have an x squared. You cannot fit x squared into an x because I have a higher degree in a divisor than compared to what we have as a remainder. So this is the extent of how far I could go. So my answer, 3x minus 2, our quotient, plus 3x plus 3, our remainder over our divisor, which is x squared minus 1. You will always leave your answer in this format. Okay, so what is its use? Now, I'm going to get to the bottom of something like this. I'm going to get to more this topic later on. But today, I just want you to slowly focus on just getting the long division down. But the use of this tactic is to be able to find out the zeros of the function, basically. And I want to go back to this question where if I wanted to factor cubic functions, can I really do this by using what we call long division? So let's say that I'm dividing this by x plus 2. So x cubed minus 5x squared minus 2x plus 24. If I were to divide this by x plus 2, and if you were to do the math, or if you would like to just pause the video and just try it on your own first, and then let's check the answer afterwards. Alright, so here we're going to get x squared, and then we're going to multiply these two and get x cubed, and then this becomes plus 2x squared. Now subtract these two, and what I would get is, make sure you distribute them. So this becomes minus 2x squared, so minus 7x squared. I'm going to distribute the signs once again. And then this minus 2x comes down. Then I'm going to have this term with this term, so that becomes minus 7x, because that's how many times can x fit in negative 7x squared. Multiply these two, you get minus 7x squared minus 14x. Subtract these two together, and you get 12x. Bring down the plus 24, and then how many times can x fit in positive 12? Well, 12 times. And here, what happens is that I ran out of space, but x times 12 becomes 12x. 2 times 12 becomes plus 24, and when you subtract them, all of these will cancel out, and you get a remainder of a 0. So what does that mean? This is simply x plus 2 times our quotient, which is x squared minus 7x plus 12. Now, can this be factored? Absolutely, because we're going back to the chapter of what we already discussed, factoring quadratics. So then I literally just factored out a cubic function using long division. I get this equal to 0, and I can say that my 3x intercepts, because now I have a cubic function going through 3 separate points on the x-axis, are at negative 2, positive 3, and positive 4. So this is its use. Long division allows us to calculate zeros of the polynomial functions. That's the purpose of this. So this is the main topic in which I want you to focus on. But as again, today we're going to be talking, or your homework is just going to be solely based on the technical aspect of long division today. All right, so make sure you get your work done by the end of today, or by tomorrow, 8 a.m. And I'll see you guys tomorrow with more about long division / synthetic division. Thank you and have a good day.